Hello students. So let's start with the next session of Introduction to SDLC. I am Dr. Alifia Jagirdar, Assistant Professor of Abida Namdar Senior College. If you like this video, do press like button and share it with your friends and subscribe it. So let's go ahead. In this particular session, we are going to see two models. One is prototyping model, the other is spiral model. So let's go ahead with it. Prototyping model. So the prototyping model is systems development model. It is called as SDM, in which a prototype is built, tested and then reworked as necessary until an acceptable prototype is finally achieved, from which the complete system or product can now be developed. This model works best in scenarios where not all of the project requirements are known in details ahead of time. It is an iterative trial and error process that takes place between the developers and the users. Sometimes user have a clear idea of objectives of the software, means he knows input, processes as well as output requirements, but he is not sure as to how it should actually function. That is, he doesn't know what will be the actual working process of a software. On the other hand, developer may be unsure, means he is not sure about the efficiency of tools and algorithm which he has used to solve the problem. In such type of situation, prototype is best approach to solve the problems. Okay, so prototyping is defined as the process of developing a working replication of a product or system that has to be engineered. It offers a small scale of facsimile of the end product and it is used for obtaining customers' feedback. Let's take an example of the construction company. Whenever you go to book a flat, they will always show you all a small model, a working model, or you can say a replica of the actual product. The customer gives the feedback and on that the refinement is done. Once the refinement is done, again tested, again customer feedback. So facsimile means a small scale of end product is understood, that how this is how the after the construction the building will look. So prototyping will always consider the customer feedback. It will define and it will develop, refine the prototype and again test and give back the result to the customer. It is one of the most popularly used in SDLC model. This is where the customers do not know the exact project requirements beforehand first. In this model, a prototype of the end product is first developed, tested and refined as per customers' feedback repeatedly till a final acceptable prototype is achieved, which will form the basis for developing the final product. Okay, so here in prototype, the end product is developed first, it is tested, it is refined and taken the feedback from the customer till we get our final result. In this process, the system is partially implemented because we are going to give them a small overview of the working model. So it has to be partially implemented before or during the analysis phase, because then only the customer has an opportunity to see the product early in the life cycle and give the feedback. The process will start by interviewing the customers, developing the incomplete high-level paper model. This document is used to build the initial prototype, a small model you can say, or model based you can say, supporting only the basic functionality as desired by the customer. So once the customer figures out the problem, the prototype is further refined to eliminate them, and this process will continue until the user will approve the prototype and finds the working model to be satisfactory. So prototyping model has different phases. There are 6 phases. First is requirement, quick design, build prototype, user evaluation, refining prototype. Now please see this particular diagram. The refining prototype again goes to user evaluation again goes to refining prototype. So this is the circular input output where it is going to do the continuous analysis, continuous testing, continuous designing and then giving the better result. Implement and maintain. So let's see. Requirement gathering. A prototyping model will start with the requirement analysis. In this phase, the requirement of the system are defined in detail. During this process, the users are interviewed to know about their expectations. So user is interviewed or survey is done to understand the user requirements. The next is quick design. This is also termed as preliminary design. Okay, here the simple design of system is created. However, it is not a complete design, means it is not the final design, and it gives a brief idea of the system to the user. So a small brief idea is given to the user that this is how the system is going to look, and the quick design will help in developing the prototype. Step 3, you're going to build the prototype. In this phase, an actual prototype is designed based on information gathered from quick design. Okay, it is a small working model of the required system. So as I gave you an example of a builder who constructs a building, they will have a small miniature model of their building. So step 4 is initial user evaluation. This is the where the client is presented for your initial evaluation. It is going to help you to find out your strength and weakness of the working model. They are going to give you the feedback. So the comments and suggestions are collected from the customer and they are provided to the developer for again refinement. Okay. So here, if your user is not happy with the current prototype, it is again going to refine your prototype according to the user's feedback and suggestion. This is not over, or this phase does not get over until your requirements meet with the user's expectation. If your user is satisfied, then you go ahead with your final system. Last is step 6, where you're going to implement your product and maintain. Once the final system is developed based on the final prototype, it is thoroughly tested, deployed to the production, and this system undergoes routine of maintenance for minimizing the downtime and prevent large scale failures. Types of prototyping model. There are many types of prototyping model. There are which here we are going to see 4 prototypes. First is rapid throwaway prototype, evolutionary, incremental, and extreme prototype. Rapid throwaway says that once, or it is based on preliminary requirement, and it says that once you get the or you develop the prototype, you will discard and it will not be used again. So that is rapid throwaway prototype, where you throw away your prototype and you don't use it again. So it is quickly developed to show the requirements, will look visually. The customer's feedback will help to understand and change the requirements. The prototype is again created until the requirement is baseline. So here the developed prototype will be discarded and will not be part of the untimely accepted prototype. This technique is going to be helpful for exploring ideas and getting instant feedback for the customer's requirement. So rapid throwaway prototype, it will give you the instant feedback for the customers. Evolutionary, here it is also termed as incremental prototype. It is based on the refinement of the system on the basis of customers' feedback until it is accepted. So it is going to help me to save my time as well as effort. This is because developing a prototype from scratch for every interaction of the process can sometimes be very frustrating, because sometimes you may stop doing it, because again from the scratch you're doing it the same thing again and again, which may remove your interest. So this model is helpful for the project which uses new technology that is not well understood, because if you don't know the new technology, the urge of learning, understanding and then refining becomes more strong. So it says that if you do not understand the new technology, then this is the evolutionary prototyping can be done. It is also used for complex projects where every functionality must be checked once. Complex projects where the functionality have to be checked. It is helpful when the requirement is not stable or it is not understood, because evolutionary at every stage you can always improvise your requirements. Okay, so incremental prototyping, here the final product is decimated into small prototypes and developed individually. So the different prototypes are merged into a single product, and this method is helpful to reduce the feedback time between the user and the application of development time. So that is called as incremental prototyping, which we had seen in the last session. Extreme prototyping, it is basically used for web development and it consists of 3 sequential phases. Basic prototype will with all the existing pages present in HTML format. You can simulate data process using prototype service layers, and the services are implemented and integrated into final prototype. So extreme prototyping is used for web development. This is where we have shown the prototypes, different prototypes. Initial set of user requirements are done, then a quick design is done. Refine the requirement, develop the prototype, evaluation of prototype by the customer. If it is yes, then go for refine prototype, test the final product, deliver and maintain. So this is called as evolutionary prototyping. But if it is not accepted, then throw away that or discard the prototype, develop final SRS, okay, design, implement, test, deliver and maintain. So this is called as rapid throwaway prototyping. Okay. Advantages: the customer can see the partial product very early in the life cycle. This will ensure the satisfaction of the customer, and it is at the comfort level that customer knows, okay, my system is getting developed. New requirements can be easily accommodated as there is scope of refinement. Missing functionalities can be figured out. Errors can be detected much earlier. Therefore, it saves a lot of effort and cost, and it enhances the quality of software. The developed prototype can be reused by the developer for more complicated projects in the future. So flexibility in design is also one of the advantages, okay, of prototyping. Disadvantages: there may be too much variation in the requirement each time. So prototyping cannot be evaluated very easily because every time the requirements changes. Poor documentation because there is continuous change in customers' requirement. It is difficult for the developers to accommodate all changes demanded by the customer. For example, your system is at the last stage and your customer comes and tells you to change one of the requirement which was initiated at the initial stage. So it is very difficult for the developer to accommodate all the changes. Uncertainty in determining the number of iterations. We don't know how many times we have to run that test, design and all those cases. So the number of iterations is very uncertain. That is going to be required before the prototype finally accepted by the customer. So we don't know what is the customer satisfaction level, at what time we have to stop. After seeing an early prototype, the customer sometimes demands the actual product to be delivered soon because there is an excitement and they understand that, okay, my project is in working condition, it may be delivered at early time also. So it is one of the disadvantages of prototyping. Now next is spiral model. This is one of the most important model which is going to reduce the risk involved into the model. Okay, so the spiral model will say it is that it combines the idea of iterative development with the systematic control aspects of waterfall. So here there are two models which are merged together, that is iterative and waterfall model. So spiral model is combination of iterative and sequential linear development model, that is called as waterfall model, with a very high emphasis on risk analysis. So spiral model revolves around risk analysis. It is going to allow incremental release of the product or refinement through each iteration around the spiral. So let's see how it looks. The spiral word itself says that it is revolving around an axis, so that is spiral. Now if you see this diagram, this is an axis, okay. So it is an release cumulative cost axis, and these are the quadrants: first quadrant, second quadrant, third quadrant and so on, the quadrants. So first is objective identification, then your alternative evaluation, that is progress, here then is product development, and then is next phase planning, okay. And this is review, release, cumulative cost, alternative evaluation. Your risk management, prototyping, design, code, integration, test, implementation is done. And if you see these spirals, these are very close to the axis, so risk analysis is done and it reduces your risk in the software development life cycle. So let's see the phases. First is identification phase. Let us go back. Objective of or identification. You need to identify the requirement, you need to identify the need of doing that software. This phase will start with gathering the business requirements in the baseline spiral, okay. In the subsequent spirals, as the product matures, identification of system requirements, subsystem requirement, unit requirements are all done in this particular quadrant, this phase. It also includes understanding the requirements, system requirements, by communicating between the customer and the system analyst. So they have the communication established between the customer and the system analyst. And at the end, the product is deployed in the identified market. So identification is done. Now comes the design phase. Identification of the requirement done. We're going to design it onto the conceptual design in the baseline spiral, and it involves the architectural design, logical design, physical design, and final design in the spiral. The next phase is construct or build. In this phase, it requires to produce the actual software product at every spiral. Okay, when the product is just thought of and the design is being developed as POC, that is called as proof of concept, is developed in this phase to get customer feedback. Then in the subsequent spiral, with higher clarity on requirements and design, develop a working model of the software called as build, and it is produced with the version number. These builds are sent to the customer for feedback. Please understand, the moment a new software is into the market, it is named as build 1.1, 1.2, 2.0, 3.4. So those are called as versions. Those many number of systems are introduced into the market for the customer's feedback. Okay. Evaluation. Risk evaluation or risk analysis will include identifying, estimating, and monitoring the technical feasibility, how well your software is technically sound. Management risks such as schedule, slippage, and cost overrun. We understand what are the risks. Sometimes my project may go overboard my schedule. Sometimes it may go, my cost is overrun. The budget is of 1 lakh and my system takes 2 lakhs. So that is overrun. After testing the build, at the end of first iteration, the customer will evaluate the software and will provide you the feedback. Okay. Now what are the applications? When there is a budget constraint, the risk evaluation is important for medium to high to risk projects. On long-term project, commitment becomes a potential change to economic priorities as the requirement change with the time. Customer is not sure of the requirement. So usually the case requirements are complex and needs evaluation to get clarity. New product line which should be released in phases to get enough customer feedback. So this is the application of your spiral model. First is your budget constraint and risk evaluation, then your potential changes in economic priorities and requirement changes with time. Customer is not sure about what exactly he wants, and new product is to be released with the same timeline, okay, for the customer's feedback. Advantages: changing requirements again can be accommodated. It allows extensive use of prototypes because it is merge of two prototypes. Requirements can be captured more accurately. Users see the system early. Development can be divided into smaller parts and risky parts can be developed earlier, which will help in better risk management. Now students, when we tell you all to do a project, I would suggest you all, rather doing a login module first, you should always develop those modules which are risky. For example, you are doing a project for Superstore where billing module is very important. So you should do the billing module first rather than doing a login module. Disadvantages: management is more complex. End of the project may not be known early. It is not suitable for small or low risk projects and it could be expensive. Process is complex. Spiral may go on indefinitely. Large number of intermediate stages will require excessive documentation. So these are the disadvantages of spiral. Assignment: you can take it as homework. You can write down on a piece of paper. What are the advantages of spiral model? We have studied different stages of software development life cycle, so you can write down those. And what is a prototyping? I hope so you all will do this assignment for your further understanding of your SDLC. And thank you so much for watching my video. Thank you so much.